Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to go over how to set up integrals for area calculations. So what we're going to do here, we're looking at two curves here. I've got the first curve is going to be x equals y squared. X equals y cubed. And then the second curve we're going to look at is the curve x equals y squared. I've already got a real rough sketch of these. These cross at the point 1, 1. And what we're going to try to do is we're going to set up an integral to find this area right here bound in between them. Now, when you're doing an integral calculation, the first thing you have to realize is, your work is going to depend on how you set up your rectangle. So I'm going to go ahead and set it up two different ways. I'll probably just actually numerically work it one way, but first I'm going to set it up here with a vertical rectangle. I'm going to go ahead and leave this in blue. So I can draw a little better rectangle than that. So you imagine a rectangle here, and the problem is really all about the rectangle now. The rectangle's width is a dx, and its length is the difference between these two y values. So I'm going to put this down here. Right? The length of that rectangle is going to be the top y value minus the bottom y value. Now the top y value from this equation right here is equal to x to the 1/3. And the bottom y value is the square root of x, or x to the 1/2. So the length of this blue rectangle would be x to the 1/3 minus x to the 1/2. You always do the upper curve minus the lower curve. The area of that rectangle, that would be a dA, is equal to the length, x to the 1/3 minus x to the 1/2, times its width, dx. The total area we get by summing these all up, and that's what the integral does. This symbol literally is a stretched s for sum. So it's going to be a sum, basically, 0 to 1 of the quantity x to the 1/3 minus x to the 1/2 dx. And if I go ahead and work this out, the antiderivative of x to the 1/3 is x to the 4/3 times 3/4. And that's going to be evaluated 0 to 1 minus antiderivative of x to the 1/2 is x to the 3/2 times 2/3. And again, that's evaluated 0 to 1. So this one's going to be 3/4 times 1 minus 0. 1 to the 4/3 is still 1. 0 to the 4/3 is 0. Minus 2/3 times x to the 2/3, or 1 to the 2/3 is 1 minus 0. And what we get out of that is 3/4 minus 2/3. So let's see, 9 minus 8, 1/12, I believe, for the area bound within that region. I'm going to go ahead now and talk about what would it look like with horizontal rectangles. Had we drawn the rectangles horizontally, which is perfectly acceptable, the width of this rectangle is now a dy. The length of that rectangle is going to be this distance minus this distance. So that's this x value. This was the curve defined by y to the 3rd. Minus, whoops, got that, y squared. Right, because we want the bigger x value, that's this one defined by this curve, minus this x value, which is defined by this curve, so minus y cubed. The area, dA, of the green rectangle is length times width, so that's going to be y squared minus y cubed times dy. And again, that's just area of a rectangle, length times width. Total area we get by adding these all up. Now we're adding over y this time, so you got to imagine these green rectangles doing this, like starting here and moving higher and higher and higher and higher. Right? The smallest value they can be is 0, and the highest is 1. y squared minus y to the 3rd dy. And then y squared integrates to y to the 3rd over 3, 0 to 1. Minus y to the 3rd integrates to y to the 4th over 4, again evaluated 0 to 1. This is going to give us 1/3 minus 0 minus 1/4 minus 0. Common denominator is a 12, so 4 minus 3 is 1 over 12. 1/12 square units. I should have put some units on there. Go back, square units. So again, this video is just meant to be a relatively simple example of how to set up an area calculation with either a horizontal or vertical rectangle. Which one you use, it depends on the function and the curve and the specific examples. You know, there's not a right or wrong to that answer. Sometimes it's easier to set up using a vertical, sometimes a horizontal. Hope this video helps demonstrate these concepts. Have a great day.